Hello, it's me again. I'm going to continue on with the clamshell bucket repair. The frame I tacked together the other day and sent out to the welder, and I just got it back, and I was just going to set it up on the mill to do a bit of post-weld machining, and I run into a problem, so I thought I'd show what can sometimes be a common problem when you're working at the limits of your machine's capacity. This is the frame. See, it was it's all welded up. I was quite happy there wasn't too much distortion. It humped up in the middle just like the original frame did, and it's about 1/8 of an inch it came up. So that's not too bad. I'm gonna have to remove that because the piece, if you go back to the first video, you'll see laying on the floor a large piece that attaches to the machine and that this bolts to, and it's quite a bit thicker and stiffer than this frame. And the original setup, the bolts are here and here, here and here, and if you bolt that to that part, it'll likely cause the frame to warp. So I'll do all the work to get it, get the holes bored in straight and everything like that. And then when we bolt it down to the piece, if this hump is in it, then it's likely gonna warp again and go out of line. So my plan is to take a skim cut along here and clean this up. What I was gonna do though first, what I have to do is, and I mentioned this in the earlier video, machine here and here so the boss plates can go in. Now, my plan was to machine it. I'll just use this as an example, using an end mill like this to just sort of come in and cut this away. In fact, I need a little bit longer end mill. Maybe one more like this. But if we look here, you can see that there's no way I can get a end mill holder in that vertical head and have it not interfere with the part. I guess what I'm trying to say is the part is too tall. I've got the knee bottomed out. Right now it's as low as it can go, and you can see that the frame is too high. So yesterday afternoon I spent a little bit of time scratching my head trying to figure out how I'm gonna actually machine this now, and I came up with a plan which is roughly drawn out here. The first step, this is looking at that frame from the end. These two pieces up here are these pieces here. My plan is to mount it essentially the way it's sitting on the milling machine right now, overhang it past the table slightly, and then go with the face mill and machine the edge. And that'll be this edge. You know, these pieces were 3 separate pieces here, the bottom and the other side. I tacked them together holding it by hand, so these aren't necessarily perfectly in line. They were welded and then the welder cleaned them up, so I can't rely on this to be a flat surface. So if I slide this over so it overhangs the edge of the table, and I take the vertical head off and use the horizontal spindle, I can come in here. I can come in here and clean this edge up and get myself a flat edge. Then the next step is to take the piece and lay it on that edge, lay it on the edge that was just machined, and overhang it over the back of the table again slightly, and expose what's currently the bottom of this frame the way it's sitting on the mill. So essentially turn it so that this surface under here that's got the hump in it will be facing the milling machine. Then I can take passes. Again, this is supposed to be my face mill. This face mill. I can take passes and get it flattened out, get rid of that hump. And then once that's done, I can mount it on the table in the opposite direction to the way it was here, where it still sits on the side that was machined in step one, and the back side is facing in the opposite direction now. But now I can run a dial indicator along that back side while I move the table back and forth, and I can get the back side parallel to the travel of the table. Then I can come in with the end mill and the horizontal mill and machine this for these pieces exactly the same way as I would have with the vertical mill, except, sorry, with the vertical head, except this part will be laying over on its side, and I'll do it with the horizontal spindle, which is up there. So that's the plan. It's a little bit more work. I have to take the vertical head off, but at least I can do it, and I end up with all the same surfaces machined the way I want them. So it should work okay, I hope. Anyways, we'll see how it goes. In order to do the milling that I was just talking about, I have to remove the vertical head. Thought maybe I'd just show how that's done on this particular mill. I'm sure they're all fairly similar. But anyways, I'll just show you do it on this one. This head is held with 4 bolts, 2 here and 2 on the other side. That holds it to the column. Inside of here is a piloting diameter, and around the spindle is a diameter that sticks out that meshes with the piloting diameter to ensure this is mounted concentric with the spindle. Because inside the spindle is a 50 taper arbor with a spline shaft sticking out of it that meshes with a female spline in here to drive the vertical head. So it needs to be lined up fairly close. This vertical head is also held here, and when you tighten those, it pushes pins in and it drives a movable gib into the dovetail of the overarm. And this overarm is actually on the body of the mill. When you tighten these, it actually pushes on the overarm and drives it in that direction. So what it does is it forces the overarm against the dovetail on the far side, which is obviously very accurately made. So it's always being pushed against the same surface. And then tightening these on the vertical head does the same thing. It pushes the vertical head. It actually draws the vertical head against the opposite dovetail. So in effect, it causes the dovetail on the opposite side of this to register against the dovetail on the opposite side of the overarm, and the dovetail on the opposite side of the overarm registers against the dovetail on the body of the mill. So on that far side, all 3 of those dovetails are tight against each other, and it's good. It adds rigidity. And I think the main reason for it, though, is so that once you tram this head in, when you take it off and you put it back on, it'll be piloted around the spindle, and these bolts will hold it fairly close, but there always has to be clearance between the bolt and the hole. So this thing could tilt left or right if you're standing in front of the mill looking at it. So by also holding it with the overarm, it prevents that degree of freedom, or that motion, I guess you could say, and it keeps the head trammed. And I've checked it. I've trammed the head, taken it off, put it back on a few weeks later, and the tram has been pretty good. So we obviously hit upon a pretty good system there to keep that lined up. Now, loosen the overarm from the body of the mill. I'll take the bolts out and hold it to the column. Oh, I do tend to leave these on. These you can just take right out. The head can't fall off. It's being held by the overarm right now. Even though the overarm is loose in the column, it's not going to fall out. There, so now the 4 bolts that hold the head to the column are removed, and the overarm is loose. So if we were to push on the overarm, it and the vertical head should slide away. Now, when I first got this mill, I wasn't sure how to do it, and I used to loosen these off and try and slide that off the overarm. Problem is you're trying to remove it from the overarm and remove it from the pilot diameter at the same time, and they can fight each other, and it can make it pretty difficult to actually get this off the mill. I found that by leaving it attached to the overarm, pushing the overarm, it guides it pretty straight, and you're not fighting 2 different features when you're trying to take it out. Let's see if that's going to make it fly or not. No, that worked. So you can see the spline shaft. It drives the female spline in there, and then this diameter is the pilot that rides inside of this bored hole. It's a very close fit, so that keeps it concentric for the shaft alignment. Up here you can see the gib that gets pushed by these pins when you tighten the bolt down. So now what I can do, whoops, fire the camera, man. Now what I'll do is I'll just snug this one back up so the overarm doesn't slide out. Now I got this on the crane already. Now I should be able to slide the head off the overarm and at the same time let the crane take the weight. That's what the back of the. Show you what the back of the. So that's what it looks like there. Again, just that spline, female spline. There's a series of bearings and lots of grease, gears, stuff like that in there. But I've stripped this actually and cleaned it and put it back together, and everything in there is nice and big and heavy. So that's good. Now I'm setting this. I'm setting this up. This is step 1, so I can machine this surface with this face mill. So I need to get it roughly parallel to the travel of the table. So what I'm excited to do is just use my sliding square and a 1, 2, 3 block and set it using the back surface because it's easier to get at. So I just put that against the back of the table and then put the 1, 2, 3 block against here, and then I can just push it until it touches, and then just repeat the same at the other end. So on there, push till it touches, and it is, and that'll be good enough to line up for the initial machining. I'll check that again. I still got to sell my clamps up and everything. I'll likely knock it out of place, so I'll get it clamped up, and then just before I snug it down, I'll check that again. To clamp this down before I mill the edge, I wanted to clamp it near the ends because it's actually resting down here and here because it's humped up in the middle. So probably the easiest way is just to clamp it at the end and down to the table. And I just got about a month ago, I got these 2 Armstrong planer jacks. They're 8-ton jacks off of eBay, and I cleaned them up and got them working. They were actually in pretty good shape when I got them, but I just cleaned them up and put some moly coat on the threads. So this is my first time using them. I'm just going to use them as like a block to hold the clamp up to brace the back of the clamp. Anyways, I'll just show you how I'll do that. So I had to extend these. This is pretty high, so these coupling nuts that come with your clamping kit come in quite handy. These are the clamping bars I made before. I think I showed them in an earlier video. I think when I was actually clamping the other one of these down, I used these. Very handy for big stuff like this. There. I'll slide the, as most of you know, when you clamp, you want the bolt as close to the object that you're clamping as you can get it. So I can slide that in until it's almost touching. I don't like to go right up against. I like to be back just a little bit so there's some weight on the block so it doesn't loosen up. But there, that's the one. And with this setup, it leaves me enough space here to get the square through with the 1, 2, 3 block to check the alignment with the table. Nice thing with using the planer jacks for this is that you get kind of infinite adjustment. You can get your clamping bars as level as you want. It's nice. Now, one thing I am doing is the line of force of the clamp is here, and so that's being applied here on the frame, and of course it's touching here. So there is a moment arm here that can cause twisting. However, this is very heavy and thick, so it likely won't spring, and if it does, it doesn't really matter all that much because I'm machining this face, and if this were to spring this way, it's not necessarily going to cause this edge to move in or out. So I don't think it'll be an issue. And it's just a lot more convenient being able to clamp that way, so. Oh yeah. Before I do that, I gotta check the alignment again. That's just touching. So they're aligned about as parallel to the table travel as one can get. Now I can tell this is not going to flex much because the wrench goes from easy to very hard to turn very quickly. Meaning it's not really springing. If it was springing, then you get that spongy feel on the clamp bolts and tightening them. This is not spongy at all, so I think this is pretty solid and hasn't sprung. So I think we'll do okay with this. Now for speeds and feeds on the milling machine. Before I had this milling machine, I just had my Bridgeport clone with a variable speed drive power feed on the table. So you never actually knew how fast it was going. And it just became a matter of just experience and judging how the cut was going and making adjustments on the fly. With this mill, it's actually got, like most mills like this, has a definite discrete set of feeds. So I made a chart up to help me, and get this to stay out of the way. What I did is I made this surface speed chart. So I have the cutter diameter down the side, all the way up to 16 inch, which is unlikely, but there was room in the spreadsheet. And then across the top are the actual spindle RPMs that are available from the gearbox. And then in each cell, it just tells you if you've got a 1-inch end mill, let's say, and you're running it at 142 RPM, you'll get 37.2 feet per minute. It's not normally how you use this chart. Normally you know the surface feet you want, and you know the diameter, so you just go across. Say you want to run it about, that 1 inch you want to run it about 60, you just go across, and there's 60.7. Not sure if you guys can see that or not. That's 232 RPM, so you can set that. I got this thing, came with a Cleveland end mill I got, and it gives you a recommended surface feet per minute, so I just staple it on as a guide. And then I have these charts, and this is to calculate the feed. And what I've done is each page has a tooth number up to about 10. So I'm if you're using a 1-inch end mill with 4 flutes and you wanted to run at 60 feet per minute, you'd say right there, 60.7, which is 232 RPM. It's got 4 flutes, so you go to the page with the 4 teeth. And then you know the chip load per, you get the chip load per tooth from the tool manufacturer. They'll give it, or from other tables. But knowing the speed you're going to run at, which is 232, and saying you want, I don't know, 4 thou per tooth, you go to 232 RPM, which is what you're going to run it at to get the right surface feed. You go down here till you get close to 4 thou. Right there's 3 9/10. Then you just come across and there's the feed rate, 3 and 39/64. And these are the actual feed rates on the feed box of my milling machine. So it makes it pretty quick, because I was sort of lost. I was having to calculate these each time I went to get a tool. So I just took a little bit of time and made these spreadsheets, and they've been very helpful. So now, having said that, for my face mills, the two that I have, I found some speeds and feeds that worked, and I just jotted them down on the front page. So I'm going to use this 3-inch face mill, so I'll run it at 650 RPM and 10 9/16 inches per minute, at least to start, and then we'll see how it goes. If this is a rigid enough setup, it should be able to handle that. If it isn't, then a guy will have to change accordingly so it doesn't vibrate apart. So 650 and 10 9/16. So just go to here. This has got a pretty easy to use gearbox. There's 650. I'm on it with this lever, and then it's just that one out, that one out, and that's 650 RPM. The feed, I want to go 10 9/16. So we can see that 10 9/16 is here. So we go up. It says this lever is supposed to be in the second notch from the top, and this one should be all the way down, which it already is. So there's 10 9/16. So I got my speed and feed set. So it's pretty quick, especially if you have the numbers written down ahead of time. Or not. See the cut here, so that cleaned it up, and you'll see it there as well. So I cleaned up both, so I'll keep going with that setting and clean up the whole surface. I machined the back side of the first step to machine this part yesterday afternoon, and I had right at the end I realized I had a bunch of steps in the surface, meaning the each time I took a pass, there was a line across here, meaning the base mill was either moving in or away with each pass. So I had this rough stepped surface, and the reason for it is the knee on this milling machine has some wear, and what I was trying to do is I had the gibs tightened up. I snugged them up with the locks to try and take the play out, and obviously that didn't work. So what I did this morning, and I didn't record any of it because it's just more of the same, but I changed to my 6-inch face mill so I could do this job in 2 passes instead of 4. And then I tightened the knee, or locked the knee very tightly with the I'll show them here with the locks, the 2 levers, and it seemed to work. I've got just a very slight right here. I'm not sure if it shows up on the camera, but it's a very slight step there, but it's so small you almost can't feel it. I'd be surprised if it's even a thou. So that's acceptable. Yesterday it was quite a bit, like the steps might have been 5-6 thou. So this seemed to fix it up. So I think the rule for this job is get the knee locked solid before you do any machining, and it'll seem to keep it in line. So now, as I discussed before on the sheet on my bench there, this is the surface we just machined, and we'll lay that on the table and expose the back to the base mill. Well, it's good, no rocking, so I think it's